Okay, this is the 2008 free response having to do with differential equations and slope fields. And it's actually one of the homework problems from the slope field section in Unit 6. So you're given a differential equation or a derivative. And the first part A, says they want us to draw a slope field. So since the derivative is in terms of both x and y, there is no specific pattern that we can use. So I'm going to start with all those points down on the x-axis. So I know that down there y is 0, which means the derivative is going to be 0 minus 1. And then I'll start over, if x is negative 1, then the denominator, negative 1 squared, is 1. So the slope there is negative 1. If I move over to where x is positive 1, it won't change anything because 1 squared is still 1 in the denominator, so still a slope of negative 1. And if x is 2, then that just means it's going to be negative 1 over 4. So it's still negative, but it's just much flatter. So as long as you make it look in the negative direction and flatter, then try to make that look straight. Okay, so then I'm going to go up to where y is 1. And even though we said there's not a horizontal or vertical pattern, on this particular line, there is, because if y equals 1, then this whole thing is going to be 0, right? The derivative is going to be 0. So all across here, and make sure you only draw little segments at the points that they have shown. And then at the top, we have y is 2. So that means the derivative is going to be 2 minus 1, so 1 over, and then now it's going to depend on the denominator. So I'm going to go over to where x is negative 1, so that would be a positive 1. So this direction. If x is positive 1, that's still going to be a positive 1 slope. And if x is 2, that's going to be a 4 down there, so it's going to be a positive 1/4. So flatter, but still in the positive direction. And you may not be able to picture what's going on, but that's okay. They're not telling us to do anything with this yet. So part B, find the particular solution. Okay, when it says find the solution or the particular solution or the general solution, that's where we're going to separate and find the original function. So I'm going to bring down, so this is for letter B, I'm going to bring down the derivative and I'm going to separate. So it's going to be, the dy is going to stay on the left, the dx is going to come to the right. So I'm going to divide by y minus 1, the entire thing. It's going to leave the 1 over x squared over here. So if I integrate both sides, on the left, when I integrate, it's going to be natural log of y minus 1. And you can think of it as a u prime over u equals. And on the other side, think of that as x to the negative 2. So that means the derivative is going to become, let's see, x to the n plus 1. So it's going to be x to the negative 1 over negative 1. I'm going to think of this as natural log of y minus 1. And I'm going to think of this as negative 1 over x plus c. So if I want to get the y out of the log, I'm going to do the exponential. So it's going to become y minus 1 equals c e to the negative 1 over x. So y is ce to the negative 1 over x, and then there's a plus 1 out at the end. And if I use the ordered pair they gave me at 2, 0, so 0 equals ce to the negative 1/2 plus 1. So I'm going to solve for c, so I'm going to subtract the 1. So negative 1 equals, now I'm going to picture this as c over e to the 1/2 because of the negative 1/2. And so if I solve for c, I could multiply by e to the 1/2. So c is negative e to the 1/2. So now to finish the actual question, what is y? Well, remember, right here was where we plugged in our ordered pair. So that's where I'm going to put the c back in. So y equals C is negative e to the 1/2, and then I have e to the negative 1 over x, and then plus 1. So that's my y equals for part B. And then C, part C says, for the particular solution that you have from part B, the one that I just boxed in, find the limit as x approaches infinity. So part C is saying find the limit as x approaches infinity of that function. Now, one thing I am going to do is here's going to be my negative. And because these e's are being multiplied, I can add those exponents. So I can think of this as e to the 1/2 minus 1 over x. And then at the end, I have a plus 1. Okay. So you're like, normally limits at infinity, you think about horizontal asymptotes, but I can't use the horizontal asymptotes rule here because it's an exponential. It's not like a polynomial over a polynomial where you can do your Bobo-Botten thing. So let's think about substituting. I mean, isn't that how we evaluate limits? If I plug infinity in for x, I'm going to have negative e to the 1/2 minus 1 over infinity. And then out at the end, I have a plus 1. And we may have mentioned this before, not very much, certainly, but think about this right here, 1 over infinity. Basically, this comes up on the next section, but if you have a constant over infinity, it's just going to equal 0. And we can talk more about that later, but in general, that part's going to be 0. So what I actually have is I've got negative e to the 1/2 minus 0 and then plus 1. So my answer is simply negative e to the 1/2 and then plus 1. So that is the value of my limit.